Hello everyone. Now we will talk about the determination of equivalent circuit parameters. In the previous lecture, we talked about the equivalent circuits of the transformer. So we have some different versions of equivalent circuits, but for the calculations, we need to know the values of the resistances and the reactances on the equivalent circuits. So to be able to obtain the values of this equivalent circuits, we have some tests. So the first test which we examine will be the open circuit test. So we have some constraints before the test. We should determine the value of open circuit voltage. Why? Because according to open circuit voltage rated value, this test must be applied. The transformer must be open circuit or no load cases during this test. So our first constraint for the open circuit test, open circuit voltage. The voltage we applied from the input primary side of the transformer must be equal to rated value of the transformer. According to ratings of the transformer, if we apply the voltage and if we measure during that test the current and the power values, we can calculate some parameters. And during this test, the output must be operated at no load. So during the open circuit test, the current flowing through here will be 0 because of the no load condition. So if it is 0, all the open circuit current, the current coming from the source, will flow through the RC and XM, which represents the excitation branch. So that means by using proper equations, we can calculate the RC and XM. And we will use fundamental voltage, current, and power relation for the determination of RC and XM. They're connected in parallel with source. So because of this, we can use RC is equal to voltage square over power, active power value. And then the current flowing through that part from RC can be called as IC, core losses current, can be calculated. Then the magnetizing current, which produces the phi m, the mutual flux, which connects primary with secondary, can be calculated from the magnitude. And finally, the last parameter of this test will be the XM, and XM calculated again by using open circuit voltage and the magnetizing current from the previous calculation. So briefly, for the open circuit test, the output must be open circuited, no load condition, and the input source voltage must be equal to its transformer's rated voltage value. Okay, then the second test will come, which is the short circuit test. What does it mean? We will short circuit the output terminals during this test. We need one more constraint because in the normal conditions we cannot short circuit the output side. So because of this, during this test our constraint will be the current flowing inside the circuit of transformer must be equal to rated current. So we will adjust our short circuit current to the rated value of the transformer. So that means because of the short circuit condition, we have smaller voltage values at the input side. Generally, it will be 20-25% of the normal rated voltage value of the transformer. In addition to that, also we can measure the short circuit power value to determine the parameters. Which parameters? So for this case, instead of 0 secondary side current, we have the current of rated. And when we obtain the approximate equivalent circuit, we mentioned that the current flowing through this excitation branch is very small when we compare with the remaining part. So because of this, this small current can be eliminated during this test for the calculations, and we can determine the value of R equivalent and X equivalent, because our circuit will be, we have a voltage source, resistance and reactance series connection, then we will return back to the source. So according to that, we can calculate the equivalent impedance by using the voltage and the current values, equivalent resistance by using the power and the current square, and finally magnitude of the reactance can be calculated from impedance and the resistance values. So with this method, we can use the total resistance of the equivalent circuit. But separately, if we want to calculate the R1 and R2, or RP and RS, in that case, in addition to this test, we should apply the DC test, because during the DC voltage application of the transformer, all the reactances will be eliminated, all the correlated losses will be eliminated, so only the primary and the secondary side winding resistances will remain. But mainly to determine the general values of the resistance and reactances and the equivalent circuits, we will follow the open and short circuit tests, and according to this, we will calculate their values. Okay, thank you for watching.